So today we have a second meeting of our club, and most of students are online, so we'll record this and then they will be able to see how it can be solved. So the first question was Baguette. So we have some convex quadrilateral. So it looks like this. This is the convex quadrilateral, and then we have a padding. That means we have some distance d, and we pad this quadrilateral with these rings. So it looks like this. And what is the important thing about that is that the padding, this distance, is perpendicular. So when you see something and it says distance between this object and this object, so it means the shortest line. And the shortest line from point to the line is perpendicular line. Okay, so what we do? Here we split the picture into the portions. So first, let's take a look at each vertices and put the perpendiculars to rings. Okay, so here I will have perpendicular here. Here and here. So, what is important here is that all those portions of the railings are exactly equal to the sides of the quadrilateral. So, you just need to find the perimeter of the figure, and then you find all those portions of the railings. So, one thing which remains is this thing, yes? We have that thing. Now, quick question. So this is distance d, and this is distance d. What can we tell about this line? What is this line that connects those two vertices? Initial quadrilateral and the corresponding vertex of the railed quadrilateral. What can we tell about this line? And that's the most important thing. So if you know this property, everything else is very easy. So what is this? We know size of the quadrilateral, and we know one of the diagonals. So we know all the angles. Yeah. So what can you tell about this line? Of course, it is a bisect. Why? Because all points of the bisect line is equal distant from the angle. So, and because this is the same distance, it means it is the point on bisect line. So, these angles are equal. And that's all that we need. So, what we need? We need to know this angle. So, how do we know that? We have one of the diagonals. So, let's denote them. Let's say this is A. Is it like that? What do we know? For the baguette, we know the diagonal AC. So this is not A. Okay, let's say this is A, this is C, this is B, this is D. Okay. So in order to know this angle, what do we need to know? We just need to use the cosine theorem. Yes. So the cosine of ABC is, so we have AB squared plus BC squared minus AC squared divided 2 AB times BC. So this is just a mathematical problem. So we can know this cosine of this angle. And because this is parallel to that, and this line is parallel to this line, these angles are equal. They must be equal. So if they are equal, we found this cosine. So now what do we need to know? We need to know the half of this angle. And that's all. And, well, when you try to find the half of the angle, you have two solutions. One with positive cosine and one with negative cosine. Because sine will be the same. From 0 to 180, the sine is always positive. So once you find sine, it is one value. But cosine is different. Now, we don't look for the cosine of the whole angle, we need the cosine of the half of the angle, yes? So, because this is convex quadrilateral, it means all of these angles are less than 180. So, half of the angle will be less than 90, so it will be always positive. Based on that, we can find that. And now, how to know this distance? So, if we divide d, so let's say this is angle alpha, d divided by x, we will find tangents alpha. So, to know x, we need to divide d by tan of alpha. And that's all. And how many x we have? We have this x and this x are the same. Then we have this y, this z, this w, this w. So after you found the perimeters, you find all those angles, then you divide them by 2, you find the tangents, you divide this distance, which is the same value, by those, and then you multiply by 2 and add up to the perimeter. That's all. So the whole solution like that. But here we had one angle. Here we will have two angles. Yes? Because it's not one, it's two angles. But we can add up them. Yes, because we know the formula of cosine of that is product of these cosines minus product of these sines. And once you know the cosine, you can definitely find the sine. However, there is one catch. What is the question? It should be with approximation of 10 to the power minus 4. So, what will be the data structure that we use to store all the values? Double, not float. If you use float, you will not succeed. Why? Because to find sine, we will use square root. But we square the cosine, that's okay. But here, we found the cosine. We want to find the cosine of the half of the angle. Then we use a formula that uses just the cosine, yes? So, let's remember. What is the formula? So, we have cosine 2 alpha, which is cosine squared alpha minus sine squared alpha, yes? So, from that we can derive plus 1 minus 1. We can find 2 cosine squared alpha minus 1. So, to find cosine alpha, I will need to get cosine 2 alpha plus 1 divided by 2 and square it. Here, I do not square anything. Yes? But then I take a square root. If this had 10 to the minus 4 power, then after square root I will have only 10 to the power of minus 2, which is not enough. So if you use float, you will fail, like in the test number 4. But that's why we need to use double precision. If you use double precision, the precision is enough to get this question correctly. Any questions? So let's try to program this. And now you see that it's not like, oh, we covered some geometry at school and we will never use it. You see, we still need these formulas just to solve one question. Okay. Let's take a look at the second question. So next question is base 64 encoding. So if we have a base of some system encoding, then we use 10 digits that are numerical digits, and then the rest is symbols to match up the number. And the question is quite simple. So this table is what we need to use. So we are given every 3 numbers will map into 4 symbols. So we read 3 numbers, we output 4 digits, 4 symbols. And how to solve that? So, well, we will go from symbol to symbol, or we can go like in triplets. It doesn't matter for us. If you want to store them somewhere, it's not necessary. You can just create a loop and read some numbers and then try to work with them. That's all. So, n can be divisible by 3 or not divisible by 3. So we will look into that at the end. So let's say that we store some previous number that is initially 0. Then in cycle 0 I plus plus. So here what we do is we scan. Why do I use C++? Because it's very easy to scan just hexadecimal number and to some current. So this current number is a new 8-bit number. Yes? So now what we do, we already had some previous number. So we will get, okay, previous is my previous number shifted to 8th position and then XORed with current. So why do I do this? When I read first 6 digits from here, I will have 2 more digits from the previous number, so I don't need to lose them. Yes? I need to remember all of that. Now I read more, 8 more numbers. So my number will be 10-bit number. But I know that I only need first 6 digits. Yes? So we have some substitution table that just array of all those symbols. So it is just you create a string or char stump of that as a string, and then you need to look into that symbol. So what we do is we print just one character. Let's say that this is str or. So we will shift previous. So now we have 10 digits, 10-bit number. We only need first 6. So 4 are not needed, so we shift to the 4. Then just in case, end with 63, and that's all. Yes? After that, what we use, so previous will be some number. But it is when I is equal to what number? It is the second number, yes? So we do this with the second number. But with the first number, we shift to 2. With the third number, we shift to 6. So you need to have some keys. So we have switch keys or something like that. You can just use if I has a remainder when divided by 3 that is equal to 1, then you get 4. If it is So now we will store previous as the rest, the digits we didn't use. So it will be previous and some number. So if it is first, it is one number. If it is second, another number, etc. So usually it is 2 to the power of how many digits minus 1. That's why here we have 63. So if we shift by 4, we need only 4 last digits, so we will have end 15. If we shift by 2, then end with 3. If we shift by 6, 2 to the power of 6, yeah, just 63. So these are the numbers you need to do. They are all inside of this if. So one if for that, one if for that, etc. So once you finish to read all the numbers, it might happen that you didn't fill the whole table. So n might not be multiple of 3. So you need to pad with 0 digits. And you just need to have something. So if n divided by 3 has a remainder of 1, then it means we read only one number. We have 2 more digits. So we add here 4 zeros to previous, yes? So it will be just, so we need to output, you can write this one, doesn't matter. So I try to use consistent with printf. Okay, see, here I will leave some space. So this will be str of previous number shifted to 4 positions, yes? So it will automatically pad it with zeros. And now, how many more zeros do I need? So I padded this with 4 zeros, and then how many symbols? 2 symbols, yes? So just 2 zeros. And then backslash n. So else, if n is equal to 2, then I need to print. So if I have 2 numbers, then I need to pad the last number with 2 zeros and then 1 zero, yes? So it will be 1 0, backslash n. Now str of previous shifted to 2 positions. And else just backslash n. So this is the finalizer. If n is not multiple of 3, we need to pad with some zeros, and this will do that. You already know that the remaining are zeros. You already know how to change 0 to 0. Yes, so you don't need to run the algorithm again. You just can write zeros. So it's easy. Any questions? So it's very quick, fast algorithm. Just in one sitting. Okay, compare. So I've seen many people try that. I can tell you that I also fall into the same trap because it was not written so clearly. They say both integer and fractional parts contain no more than 100,000 digits. And you think combined. And it is wrong. It has at most 200,000 digits. So if you don't account that, then your program will hit time limit. Because your program tries to read number, then it doesn't have enough buffer, it waits for you to give more, and you don't have more, and that's why it doesn't work. So we need to have more. Once you create enough buffer size, then that's okay. So, how to solve this? I think it's very obvious, yes? So what do? We need to remember the length. So we need some length of the digits. That's okay. So first thing is we need to know where is the dot. So where is the dot of the first number and where is the dot of the second number? So if we found a dot in the string, then the dot is its position. Okay, we know that. But if we didn't find, it is the last symbol. So after. So okay, so it's either some position, or n0, which is the length of 0, and the same. So some position, or n1, which is the length of number 1. We know that. Now, what do we need to do? First thing first, dots must be aligned. So if you want to compare two numbers, both dots must be at the same position. Then you can only compare them. So what do we know? It can be not the case. So what I did for me to simplify the code, I created I1 and I2, and then if dot 0 is less than dot 1, I just swap it. Then I1 is 1 and I2 is 0. So now instead of looking at them as 0 and 1, I can look at them as I1 and I2, and always I1 will have dot further than I2. So what should I do next? I created some zeros, which is some or just simple 0. And then I try to compare number I1 with zeros for exactly dot I1 minus dot I2 positions. So in C it is as there N, C, and P. N means that for exactly this number of positions. So I don't look more than that. Just for exactly this number of positions. So now, if it is not equal to 0, then the first number is greater. So it must be 0. If it is not 0, I already input I1 is bigger. I don't know which one is I1, 1 or 0. I have created some function that deal with that. I just give it the index of which is greater. So if it is not 0, we settle. But I1 is, so it's either 0, then we proceed, or non-0, otherwise I1 is bigger than I2. So here we proceed. Now, what we did is we cleared the whole thing in the front of the number. Now we can treat the remaining parts as equal. So next thing I will compare the whole thing, yes, but I need to pad it. So before that I can use strcat to pad both numbers with zeros. Yes, so number with zeros. This is just. So I replace the numbers with some padding. So I know it's enough number, enough digits after that. And now I can compare exactly the answer. It's either positive, then I1 is bigger, or it's negative, then I2 is bigger, or 0, then they are equal. So it's not long, yes? Yeah. So what was the shortcut here? That I created some sequence of zeros, yes, that I used several times. But if you just write like this, will it work? Will it fill all the digits, all of the entries with this symbol? It will only create the first symbol like that, and then the other are not like that. So you need some other functions. So what are the functions? Yeah, it's in R, but in C++, what is the function? Memset. So if you use memset, it can fill some memory with the value and how many bits, so size. So it will work. For char, it works perfectly because it's a byte-wise operation. And this is very quick. A lot quicker than if you write some loop to fill all the values. Okay. Any questions?
More about seconds to
Testing?
yes. Oh, yes.
Okay, so why is working with C, C++ is sometimes very beneficial? Is because if you have pointer of an array, so what does it mean if I have like some array I? So I want the element at the address I of this array. It is the same, so imagine this is like integer. So it is the same as if I write plus I. Or if I write 0. They are all the same. So you can add how many cells you need to skip in the array to go to the start. So instead of looking at the beginning of the number I1, we'll look at the position that is aligned when the dots are aligned in both numbers. So it is the first, it corresponds to the first position of number I2. So they now look at the same position of digits, like hundreds or thousands, digits of thousands. They look at the same position. And now that you can compare them very easily. No problem. And there is no problem with dot, yes, anymore. Because we had to add the dot here. So we need to put dot to the number, and then everything works correctly. Okay? Next. Let's take a look at the next, which is card trick. Okay. So, it is written a lot of things. Yeah. Yeah. Do you want to know what is the solution? No, I mean like, so here we have two numbers, n and m. We have two numbers. So we have n cards and m pipes. Yeah. So the answer to this question, the answer to the whole this long we put the file with the designated card on top. So it has a length m, and now the card is here, is among first m. And then you divide more, and then you divide more, and then you divide more. And after this number of operations, it will be the first number. So it's just logarithm. So simple. A very simple task. So, next question was Ginger's number. So we are given some two positive integers x and y, and you need to select two positive integers a and b so that x divided by a and y divided by b are co-prime. So the question is to find the smallest value of a times b. Not a plus b, not something like that. Yeah. So the solution is very simple. So we will select a is 1 and b is GCD of x and y, and they will be always co-prime. Because after you divide it by greatest common divisor, the second number will become co-prime with the first number. They share no more common divisors rather than 1. Yeah, that's all. So the answer is the product of those, which is just GCD. So how do we calculate GCD? Using which algorithm? Euclid. Yeah. Because it works in polynomial time. Other algorithms don't, so prefer to use Euclid algorithm. Okay. Any questions? No. Next, Ginger's sequence. So here the question is tricky. You are not asked to find the numbers. You are only asked to say yes or no. And here we will use the limitations of the problem. So, what are we limited with? K is limited with 10 to the power of 5. Yes? So we calculate the sums modulo k. Okay. What are the all possible sums? How many all possible values we can get? Like maybe not all different, but how many different sums can we get? No? So we have n numbers. We can select some of the numbers. So it will be the number of subsets of the set. What is the number of subsets? 2 to the power of n, which is very easy. So for each element, you either select this element or do not select this element for your subset. Yes? So 2 positions for each element, and then you multiply this 2 for each of the elements. It becomes 2 to the power of n. So if 2 to the power of n is greater than k, what does it mean? If 2 to the power of n is greater than k, what does it mean? If 2 to the power of n is greater than k, what does it mean for us, for this question? It will mean definitely yes. Because of pigeonhole principle. Pigeonhole principle. You know pigeonhole principle or Dirichlet principle. If you have less boxes than balls. If you put balls into the boxes, you'll have at least one box with 2 or more balls. Yes? At least one box. So you will have some remainder that will have 2 sums to be equal to that, modulo k. So you don't even need to solve the question if 2 to the power of n is greater than k. This is definitely yes. So we are limited with k as 10 to the power of 5. Yeah? So which number, which 2 to the power of n is greater than 10 to the power of 5? For which n? It will be 17. So for all n's that are greater than 17, you will always say yes, regardless of the numbers. Just read n, read k, so n is greater than 17, answer is yes, immediately. So, the one question is, what do we do if it is not? Then we try to solve. So, we will create array. So, we will create some array of the values. The solution is the same as for knapsack. The solution is the same as for knapsack. Just brute force knapsack. So we created some array. So we are limited with 3, 4, 5. Yeah, 5. Okay, let's create like 1. That's okay. That's better. So we can also write that this is all zeros, just for us. Okay, now we created the 0 array. Now we read. So we read n, we read k, and then what we do is we read all the numbers. So then we have elements of n. How do we do this? So usually we write it as star equals new int n. Yeah. So it works. And then we read in the loop from I plus plus, we read all the elements. That's the usual part. Now we go through all the possible outcomes. So we have at most n positions, yes? So if n is greater or equal than 17, we say yes, and now we can go to else. So here we do the rest. Now we create some number, and we go through this number. So we create some sum, which is 0. Now we go from 4, j is equal to 1, j is less. Can we select 0 of the non-empty? Okay, it means non-empty, so 1. Now, here I need to select at most n digits. So I do like that. 1 shifted to n position. It is the same as 2 to the power n. J plus plus. Here, I created some number j. So number j has 1 at the position in which we take element with this index. 0 at the position when we don't take this element. So I need to go through all the positions. So I will go through I from 0 to n. value sum gets plus plus. That's all. Now what I need to go through this whole array, and if I find any element that is bigger than 1, then I have the answer yes. If I cannot find, then the answer is no. So that's all. So if, let's write this like maximum of array is bigger than 1, then yes. Otherwise, else, no. That's all. We don't need to find maximum, but I'm writing it as like, if the maximum is bigger, then you have one element that is bigger. Any questions? So here, I just go through all the possible subsets of an element set. I select them, I add them up, and I just store the sum. And if sum repeats, then here we go.
What are the stuff should be inside of like 4? Is it?
Okay, which one? Oh, okay.
Some like one should be inside of.
Yeah, they are all inside of this. I mean, in C, you can, if you have only one comment, you don't need to write. Yeah.
And, this is sum. It's 0 firstly.
Yeah, here.
And
Yeah. You should. Yeah, you're right. It should be right here. Yeah. It should be here. Yes. Yeah. Correct. So we initialize every time sum with 0, and then we collect the values, and then we check for the values. Yeah. Right. So it's not here. This one closes here. So this closes here, and this closes here. Okay. Maybe even here. Ginger's line. This is the last one, yes? No, we had to have more.
GH should be factor 8, right?
EF, G.
Sequences.
Oh, yeah, here. So Ginger's line is very simple. This is the most simplest task here. So the easiest one. So let's take a look. So if we have the set of lines, 2 lines intersect if and only if their coefficients are different. So it doesn't matter what is the value of bi. It doesn't even matter. It only matters to find the point of intersection. If you don't need to find the point of intersection, if you just have a question, do they intersect? Then you only need to look at ai. So we create one loop for I plus plus, and then second loop where we go from I plus 1 to n, and if ai are not equal to aj, then our value s plus plus. So we initialize with s equals to 0, and here we go. S will have the number of pairs of lines that intersect. Very simple. I mean, like, there was only one task that was even simpler. The cut trick task. It had a way longer description than the solution. So it is usually a trick that some tasks have very long description, but if you think about it, the solution is very easy. And the last one, so the last one requires you to have some knowledges group theory. So if you have some knowledge in group theory, this task is immediately easy. So if you don't have, then this task becomes like nightmare. So we have some permutation of numbers. We are given some permutation of numbers. So usually permutations are written in a specific way. So we write, so what is the permutation? Yeah. So it is when we write 1, 2, 3, 4, etc. And here we write the corresponding numbers P1, P2, P3, P4, etc. Pn. Yes? So the question is, how many colorings are there that we can color in two colors such that this number and this number have different colors? That's the whole question. Yeah. So the question is how many colorings we have such that this number and this number are different. So this number and this number are different colors, etc. So, to know the answer, you need to know that all permutations form group. So what is a group? Who knows what is a group? Yeah. So group is a very simple thing. So you have some elements from the group. So their sum is in the group. And the inverse is in the group. You have some E in the group such that A plus E is the same as E plus A, it's just A. It's like 0. And A minus A is equal to E. So if you have all these properties, this set with this operation is called group. Okay, so all permutations are grouped. It means if you have one permutation and you apply to it another permutation, you will get a new permutation, but it is still permutation. So what is the permutation? It means that these are all different numbers. The same numbers as here, but in some maybe different order. So what is E for permutation? It is the same number. So 1 will become 1, 2 will become 2, 3 become 2. So it doesn't change anything. So you can do that. And you don't change the permutation because if you swap 1 with 1, 2 with 2, 3 with 3, and etc., you don't change anything. So it still remains A. So what is this inverse permutation? So if we swap these rows and then reorder them in correct order, so because when I put this row into the first row, they will be in different order. So now I can change them again from 1 to n, changing the whole columns, then I will get the inverse permutation. Because it will get you back. Everything will bring back. Okay. So that's this idea. And now, what is interesting about permutation? Each permutation is a product of cycles. So what does it mean? So let's write some permutation. 1, 2, 3, 4, 5. Let's say this 4, this 1, this 2, this 5, this 3. Just any permutation, yes? So this permutation is a product of cycles. What are the cycles? You start with the first number, this is 1. Where does it go? 4. Where does it fall? Where does 5 go? Where does 3 go? And 2? 1 cycle. So the whole permutation is 1 cycle. But you can have another permutation, like this. goes to 5, 5 goes to 4, and 4 goes to 3. Yeah? Does it make sense? So now, when you try to color permutation, like that, when you try to color permutation, you can do that as ginger ones only if all cycles are of even length. So let's take a look. This one is of length, yes? Only 3 numbers. So I call this white, I call this black, then I must call this, and I have 4 going to 3, which are both white. So I cannot do that. All cycles must be of even length. Because here I can do white, black, no problem. So, the question is, if you are given some permutation, you need to break it into cycles. You break it into cycles, you check. So, how many ways do we have for each cycle? So we have some numbers in one cycle, and if we color the first number as white, then all other numbers will have definite coloring. They cannot change. They must follow the procedure. Next black, next white, next black, the same way, yes? So we can only change the first color to black. Instead of white, we can change to black. So for each cycle, we have only 2 options. So first, you break the permutation into cycles. You check whether each cycle has even number of elements. And if yes, then you must raise power 2 to the power of number of cycles. And that's all. That's the whole solution. So 2 to the number of cycles if all cycles have even numbers. Even number of elements. So how do we select all of them? It's very easy. So what we do is for I, so we create some array n with all zeros. Yes? And then we create some number color, not color, cycle. The number of cycle. Okay, cycle. Let's we create 1. Now for I from 0 to n, I plus plus. So if array of I is greater than 0, then we already marked. So this element is already in some cycle, yes? So we continue. We skip. Else, we call some program, some function. So let's say mark cycles. Okay, mark cycle. So we start with position I, we give it array, and we give it the permutation. Okay? We give it the permutation. And that's all. This is the whole thing. So now we need to go there and look into the whole numbers. So how do we mark the cycle? We start with I, and we mark it with let's see here, cycle number, and now we need to make the cycle plus plus. So we don't mark them with the same number. So how do we write the whole mark cycle function? So firstly, void mark cycle. So we have some int position. We have some array, some first thing we mark array of this position with this current value. Yes? And then we say while array of permutation of position is less than 1. So first thing we do, we change position to permutation of position, and then we mark array of this position with this current value and return. So we go through the whole permutation, like I showed you, and we mark all the corresponding numbers with current value, and once we finish, we return. And the complexity of this algorithm, what do you think? Just of marking the cycles. What do you think the complexity of this algorithm? Yes, because we go to this function, mark cycle, for each cycle once. Because after we marked all the positions of this cycle with current value, we do not call this function for those positions anymore. So we only call for other positions. So this function will be called for each cycle once, and all cycles join into one permutation of length n. So the complexity is n. But then we need to check other things, then the complexity becomes not so nice. So now we need to go in the cycle for each of the things of the cycles. We need to go through all the cycles and count how many times this number occurs. So what we can do instead, we can change this function to count, because it can count and it can return. So we can simplify the way. So we can have here some value. It will start with this is 1, and then it will increase, and then it will return this value. And then we get the value, and if it is even, we multiply our some number by 2. And if it is not even, we multiply our some number, the same number by 0. And then we output the number of columns. And that's all. So that's the whole idea. Any questions? So as you see, you don't need to know just algorithms. You need to know different topics in mathematics, because they will ask about them.